Calculus Project Part 1. A local golf course has contracted Duke Energy to install lighting on the course's 18th green in an attempt to draw evening customers away from night's play. To install the wiring in the lighting, Duke Energy has two options: use a trench digging device, which is a cheaper option but also leaves a small trench where the cable is laid, or use a horizontal boring machine which drills underground and lays the cable without disturbing the ground above. The power lines must originate from the transformer, which is this yellow box right here. And in order to save money, the course manager is allowing for a trench digging machine to be used along 400 feet of a cart path. The cart path is right here, and we're allowed to use 400 drill along 400 feet of the cart path. For reasons that they don't want a trench along the 18th green, we will have to drill underneath the 18th green using a horizontal boring machine. The point where the light is to be installed is exactly 150 feet away from the 400 point along the cart path. It will cost $19 per foot to use the trench digging machine and $45 a foot to use the horizontal boring machine. We are to find the point where the horizontal boring machine begins to work and the minimum cost of installing this light. So to begin, we need to figure out how far the horizontal boring machine will need to travel so we can find the minimum cost. So we set x equal to this portion of 400 feet, because we have a right triangle right here, and the hypotenuse is where the horizontal boring machine will travel. So our hypotenuse will be equal to x squared, or the square root of x squared plus 150 squared, and 150 squared is 22,500. So we then have $45 times the square root of x squared plus 22,500 plus $19 times 400 minus x, because we will only be using the trench digging machine for that little piece right there. So then we will need to take the derivative of this equation, which I have called y, because it will show us the mins and maxes of that equation, which is where the price is either the highest or the lowest. So we take the derivative, which would be 45 times 1/2 times x squared plus 200 or 22,500 to the negative 1/2 times 2x minus 19, which I've called y prime. And the derivative, where the derivative crosses the x-axis, will be the critical points or the mins and maxes of the original equation. So it just makes it a little simpler. Our derivative equation will simplify to 45x over square root of x squared plus 22,500 minus 19. We set this equal to 0 to find where it crosses the x-axis, and we get x to equal 69.866, which I rounded there, but in the calculator we left it as a. So all numbers below 69.866 were below the x-axis, so it's negative. And then all numbers above 69.866 were positive, as this little graph kind of shows. So there's a minimum at 69.866 because it changes from negative to positive. And so that is how far x is. So we found our value right here. So to find where the horizontal boring machine will begin to work, we do 400 minus a, and we get 330.134. So our horizontal boring machine should start 330.134 feet down the cart path. And then, so we plug a back into our original equation right here, and we get 45 square root a squared plus 22,500 plus 19 times 400 minus a, and we get $13,718.82, which is a lot of money to install light.